So this problem is pretty similar to one we saw before. Form a polynomial f of x with real coefficients and this degree of 3, having these zeros. So one of these zeros is 1 plus I. And so complex zeros occur in conjugate pairs. That means if I know a plus bi is a 0, a minus bi also has to be a 0. They have to occur in pairs. If a plus bi is a 0, a minus bi is a 0. So if I know 1 plus I is a 0, 1 minus I has to be another 0. And that's our degree of 3. 1 plus I is a 0, 1 minus I is a 0. So let's put this first one in. X plus 5, right? Change that sign. A factor. Right? Because x plus 5 equals 0. Then the 0 is going to be negative 5. So change the sign. Same thing here. X minus 1 plus I. And x minus 1 minus I. I'm going to do something a little interesting here. Let's distribute in here. X minus 1 minus I. X minus 1 plus I. Okay. Here's what I want you to notice in these two parentheses here. What I'm going to do is I'm going to group these a little differently. Now let me rewrite the other one. Look at how I'm going to group these. I notice that I have x minus 1 here. And I can do that. That's the associative property of addition, right? And I have an x minus 1 here. So I have x minus 1 minus I. Here I have x minus 1 plus I. It's sneaky. But what I really have there is a plus b times a minus b. A minus b. Let me write it that way. Here I have a minus b times a plus b. A minus b times a plus b. Do you see it? A minus b, a plus b. And when I multiply those, I end up with a squared minus b squared. So look at this sneakiness I'm about to do. This is nice. A squared, a squared minus b squared minus b squared. Oh, whoa, do you see that? So x minus 1 squared is x minus 1 times x minus 1, or x squared minus 2x plus 1, right? You can multiply x minus 1 times x minus 1. And minus I squared is negative 1. Now you could have multiplied here, here, here. It just gets really, really cumbersome. So I have x squared minus 2x plus 1 plus 1. So I have x plus 5 times x squared minus 2x plus 2. Okay. And now I can distribute here. X times x squared is x to the third minus 2x squared plus 2x plus 5x squared minus 10x plus 10. So f of x is x to the third. Here we go, combine these, plus 3x squared. Here we go, combine these. I'll leave it in that color. Minus 8x. And then plus 10. There's my polynomial with those, there's my polynomial with these zeros, and of course you see the degree is 3.